Hi friends,
My
this is
friends, thanks.
hello friends.
Hello, friends.
Hi friends.
My friends.
Hi friends. So this is Krish here, and we're going to have a discussion on a demand forecasting model. The demand forecasting model which we are going to discuss today is the triple exponential model. So today we are going to discuss on triple exponential smoothing, which is also called Holt-Winters model. The beauty is that for this particular session which we are going to which are covering the ways which we can handle triple exponential smoothing. Everybody knows certain formulas which they apply, and for people who have never been or never have used this, for them it's a new experience. But people who have used this, I want to bring a new experience to them, and the new experience which I want to bring them is that I want to bring some certain kind of scenarios. So from those scenarios, we're going to apply a triple exponential smoothing, right? So let's see what are the scenarios. Suppose I'm going to use additive model, right? So what is additive model? What is multiplicative model? Those things also we're going to understand this. But before that, suppose if I am doing a forecast for sales, right? This is my sales. For example, I take some small sample data. Of course, we're going to work on the big data, normal data. So just I want to show a small sample here. Okay. So this is my data. So this is my sales data, right? So I want to understand whether my sales data has patterns, and if it has patterns, what kind of patterns it has. It is present there, right? This is what I want to understand. So what are the time series patterns we can expect in a sales data? The time series pattern which we can expect in a sales data is trend and seasonality. So let me share my screen. I think my screen is not visible to you guys, so let me share my screen. Yes, so I think you will be able to see my screen now. So, and I want to just let you know that if you have any questions in between, you can post your queries, and I'll get back to you with I'll get back either immediately or maybe after I complete this recording. I can actually I will go and see all my channels, and if I see any questions there, I'll get back to you with my responses. So I need to check whether you're able to hear me or not. Let me also just make that settings. So I think you're able to hear me. Just let me check whether you're able to hear me or not. So I have to check you're able to hear me properly. Sorry guys, for this disturbance. I want to check that you're able to hear me or not properly. Guys, for this disturbance. Yeah, I think all is fine now. So let's go back to the content. So we have a sales data, and we say that the sales data is made up of some patterns. It could be trend pattern, it could be seasonal pattern, and it could be some kind of irregularity, right? So we see there are three kind of patterns, which are trend, seasonal, and irregularity. So what we say that this the sales data can be a mixture, can be when we can when these patterns exist in a multiplicative form, where the second possibility is that where the irregularity and trend can exist together in additive form, and seasonality exists in the multiplicative form, where the third possibility that all of them exist in the additive form, right? So we're seeing three different forms of the patterns combination. One is that where trend, seasonality, and irregularity they are existing in the in the multiplicative form. Then we see irregularity and trend in the in the additive form. Seasonality is in the is in the multiplicative form, and the third option is that we see all of them in the additive form, right? So we the Holt's and Holt-Winters method cannot take this one. For this, we use a different method called time series decomposition. But the second model and the second combination and third combination, right? The whole filters methods can take care of this. Okay. Even we can try the combinations of whole filters by in the first form also. But we will try some other time. But we are going to cover this second option and third option today in this particular podcast. So we have a data, and we say that this data is made up of three, the time series components. This is the time series components, right? The time series components, the trend, seasonality, and regularity. And we say that the sales is made up of, these components are actually having a multiple combinations. So trend into seasonality into irregularity, there's a one component, irregularity plus trend is second component, and into seasonality second component. So and the second possibility and trend plus seasonality plus irregularity third possibility. So we can actually go with three possibilities, and we of course we can create multiple possibilities. We might be we must be having the creative freedom. We must actually take the creative freedom and bring up multiple possibilities. There's no doubt about this. We can actually try the multiple possibilities. And so going to cover second possibility and third possibility one by one. All right. So this is what the first thing about the combination of the time series components, right? This is the first thing which we have to look about. Now, suppose if you want to find the seasonality, suppose I'm going for possibility number two. So I want to find what is my seasonality for the possibility number two, right? So the seasonality is equal to, if you want to find a seasonality, what is seasonality? Seasonality is equal to the sales divided by irregularity plus trend. If you want to find my seasonality in the possibility number three, so the seasonality is equal to sales minus trend plus sales minus trend plus irregularity. right? So if you look at this is very important because when we set our combinations, we can correlate or we can find the other components by using these formulas. So we need to have a clear understanding what kind of combinations we are going with our time series components. Right. For example, if I want to find my irregular or maybe you know, so possibility number two, if I want to find my irregular component, what is the possibility number two? So we can go with sales divided by seasonality minus trend. And the possibility number three, we can go with sales minus trend plus seasonality. So if we have the clear understanding about our combinations of the time series components, then we can make a good assessment of our components and we can create a good equations for those components. Right. So this is a very important part when we are setting up our time series, when we are setting up our triple exponential smoothing or the Holt's Winter method, we need to understand we need to have a clear understanding what kind of combinations we are actually choosing to build a model. Okay. So this is first thing. Second thing which we have to consider is our smoothing constants. So in this also we have two combinations. The first smoothing constants without dampening effect. So in this we will have for irregularity, which also called level, it's alpha. Then we have trend, beta. Then we have seasonality, it's gamma. Then we have second kind of combinations, smoothing constants with damping effect. So the only addition will be here we will going to put one more constant, and that will be theta. Theta. That will be our theta. Sorry, that will be damping effect applied to trend, and that will be theta. So we can also work a second possibility of the Holt Winter method, where we can use a damping effect to the model. Okay, so level, trend, seasonality without damping effect, we will have three constants. The second model, which we can build smoothing constant with damping effect, where we can actually add another constant, another smoothing constant called theta. Okay, so now let's go and the third aspect is the optimization of smoothing constants, smoothing and damping constants. So we are going to use an Excel tool or optimization tool called Solver. Okay, we're going to use the optimization tool called Solver, and this tool will actually will help us to optimize the smoothing constant, and where we will have an objective to minimize the forecasting error. Okay. So let's follow this three approach. And so first we are going to work with the possibility number two, where we're going to use level plus trend, the level plus trend as our level plus trend into seasonality or irregularity plus trend into seasonality as a model, and then let's build the model. Okay. So the first step again, if ever we build any kind of forecasting models, we need to understand our patterns. So if you look at here, this one, we have a data, and let's understand the pattern for this. What kind of patterns we have? So I'll go and select this, go to insert from here, go to line chart, build a line chart. So if you look at this data, clearly showing a trend and a seasonality. So I'm saying trend because the lower value, the first value is at the lower end and the last value is at the upper end. So it clearly shows there is a trend inside this data. Then we see there is a there is a peaks at equidistant points. So if you look at here, the first peak is at 4, second peak is at 8, and third peak is at 12, and fourth peak is at 16, the fifth peak is at 20. So when we look at this diagram, it's very clear that the distance between two peaks at multiple points are equal. If the distance between the peaks at multiple points are equal, then we can say that we have a seasonality, right? So we can see there are other ways to find the trend in seasonality statistically. I will not go inside those things. I will directly go into the model. So now, if I know that the model contains the data contains the historical data contains trend and seasonality. So the moment we know the data contains trend and seasonality, we can apply Holt-Winters method or triple exponential smoothing. It means we have to smoothen three parameters. Triple exponential smoothing means we have to smoothen three parameters. What are the three parameters? We have to apply smoothen level, we have to smoothen trend, and we have to smoothen seasonality. So we have to smoothen these three different parameters or three different time series patterns. If you're smoothing the three different time series patterns, then we call this as a triple exponential smoothing. That's the reason why we call triple exponential, because we have three different time series patterns, that is level, trend, and seasonality. Or level we can also call as irregular. Now what happens is, if you look at here, I will draw a level line here. This is my average, right? It's not a straight line because I'm using, I'm not using a perfect scale for this. This is my level. If you look at here, this trend line has to be moved up, or this line has to come down, right? This line has to come down, and this line has to go up, right? This average line, which is a level line, on the left hand side, it has to come down. On the right hand side, it has to go up. So when we look at this graph, it's clearly the level line has to go up on the right hand side. That's called level plus trend. And the level line has to come down on the left hand side. It's level minus trend. So this data looks very prominent where we can use our possibility number two, that is level plus trend, level plus minus trend into seasonality. That's the reason why we are trying to use the possibility number two, because if I add the trend on the right hand side, the level line will go up. If I subtract the level line on the left hand side, the level line will come down. So if I do level plus trend on the right hand side, level minus trend on the left hand side, the level line will try to map with the trend line. So if I do this particular operation, right? So once we do level minus trend here, and once we do level plus trend here, the line will become a straight line, and this will look like this. But the problem again is that this is still not replicative with our sales history, because we have some seasonalities over here, right? We have some seasonalities here. So what we can do, if you can multiply the seasonal index to this level plus minus trend, so this straight line which we are looking at over here will become like this, right? This is straight line. Now we'll have a zigzag path. And once it gets zigzag path, or then it is going to replicate our sales history. That is what our objective is. That's why we are trying to say that we have to first do level plus minus trend, and then multiply the level plus minus trend. This is the first thing. Then what we will do? We'll multiply this level plus minus trend with seasonality. Okay. So level plus minus trend into seasonality. That's what we're trying to do to attain that particular replicative forecast, because we are trying to create a model which matches our history, right? We're trying to create a historical model. We're trying to create a model which maps our history. So in this case, if you do level plus minus trend and then multiply with seasonality, then you are going to achieve that particular objective of replicative forecast. Right? So now let's start the forecasting process. We understood all the concepts of triple exponential forecast. Now I'm going to apply all of them. First, I'll find the level constant, which is alpha. Then I have the trend constant, which is beta. I have the seasonality constant, that is gamma. Then we have the dampening constant, which you're going to apply in the next model. Dampening constant, that is theta. And then we are going to have 1 minus alpha, 1 minus beta, 1 minus gamma, and we don't need 1 minus theta here. And what we suppose, if the alpha is point, I'll take a random value, zero point 0.1. I'm going to keep everything very lowest value, zero point 0.1. And if I say 1 minus alpha, that will be 1 minus 0.1. And what I want also, that the sum of 1 minus alpha and alpha should be equal to 1, because the weightages always have to be equal to 1, right? So these things I have done. Now I'm going to apply the formula over here. So formula is of, I'll explain the formula at the bottom here. So the level forecast, we can create a level forecast in two ways. Okay, so one is, let me, alpha into sales divided by, we can do level plus trend, or sorry, sales divided by seasonality plus 1 minus alpha into the previous level forecast plus the previous trend forecast. This is one of the things which we can do. Or we can also do alpha into sales divided by seasonality minus trend. This is another possibility we can try. Plus 1 minus alpha into the same thing, the previous level forecast plus previous trend forecast. So this equation I'm deriving based upon the combinations which we have set earlier. Similarly, the trend forecast is equal to beta into level 2, the current level forecast minus previous level forecast plus 1 minus beta into the previous trend forecast. And third is seasonal forecast. This is gamma into sales divided by the level plus trend forecasts plus 1 minus gamma into same period seasonality. And final forecast is the previous level forecast plus previous trend forecast into the same period seasonality. Right? So these are formulas we're going to use. I think these are complex formulas. So for to understand these formulas, I gave the initial explanation that how the combinations of time series are made. So if to understand these formulas, we need to also go into that particular combinations of time series. So once we have a clear understanding about the possible combination of time series, it is very easy to form these formulas. So I'm going to apply these formulas now into the model. So first I'll find the level forecast. Then I'm going to find the trend forecast. I'm going to find the seasonal index. Then I'm going to find the final forecast. Okay. So let's start with the seasonal index first. So what I'm going to do with the seasonal index, I'm going to take a condition called average here. So I'm going to take a range from here. I have to do some modifications also here. I'll do the modifications. So this one, Select one because I want to get the forecast for each period of one. And then I want that forecast for this particular range. Okay, I'm going to freeze this, close the bracket. So one change I'll make here. So this is 1 to 12. I'm going to make this also 1 to 12 because that's our, so 1, then 2, right. So now we have the ready thing. I'm going to create the forecast for a seasonal index for the, I think I have to do one more thing here. So this is 1, this is 2. Okay, so this is 1, this is 2, A7 to A36, B7 to B36. Then I have to use for 1. Now, instead of using 1, I'm going to use this one, dynamic range. Now, I'm going to divide this value by the overall average. This gives me seasonal index period wise. So 0.83 the season index, right? So I got season index over here. Now what I'm going to do, I'm going to find the seasonal forecast. Find seasonal forecast, I need to have levels. So then what I'll do the first forecast is I'm going to take the same value. We can have multiple options here. The trend value also, I'm going to make it, let's say 0, the initial value. We have a creative freedom to choose level forecast as per our requirements and trend forecast as per requirement for the initial values. We can try n number of combinations here. There is no problem on that. Okay, now I'm going to use alpha. Alpha is zero point 0.1. I'm going to freeze this into the current. So I'm going to do what I'm going to divide the sales by the seasonality, seasonal index, so same period, plus 1 minus alpha, which is this one. Freeze this into the previous level forecast plus the previous trend forecast. All right, I'm going to close this. I can drag this formula as much I can. Similarly, I'm going to find the trend forecast. The trend forecast is I'm going to take beta zero point 0.1 into, I'm going to do subtract the level 2 minus level 1. This is my level 2 minus level 1 forecast plus 1 minus beta. I'm going to freeze this into the previous trend forecast, which is this. So I've got a trend forecast also. I'm going to drag this down. Now I have to find a seasonal forecast here. The seasonal forecast, what I have to do? Yeah. So for this period, if you look at here, I don't have anything on E19. So I'm going to choose the same period seasonality. Suppose that this is period number 1. We need the seasonal index for the period number 1. This is period number 1. So I'm going to divide this. So now this problem is solved. So let me go and check. And then we are going to calculate the seasonal forecast. For this, we're going to use gamma, freeze this into, I'm going to take the sales, which is this, divided by, I'll divide by level forecast, or I can also divide by level plus trend forecast. Okay. We'll try multiple combinations. So I'm going to divide this by level plus 1 minus gamma 0.9, freeze this into the same period seasonality of this. So this is the same period seasonality, right? So this is how I got my seasonal. Okay. Now we're going to have the final forecast. The final forecast is what? The previous level plus previous trend, put them into brackets into the same period seasonal index. So this is the second period. So this is what we're going to do. So this is 02.42, and then we got our final forecast, right? Now going to find the error. The error is forecast minus sales. Then we're going to find absolute error. There is also the thought process between why we need to find absolute error, why we need to find error, how to use those metrics for understanding the forecast. There are a lot of theories behind this. If you want to join a training program, you can join our training program. We'll give you absolute understanding about all these concepts in detail. So now we're going to calculate absolute error percentage. For this, we're going to divide the absolute error divided by the sales. So we're getting absolute percentage, right? Now I'm going to calculate my mean absolute percentage. So for that, I'm going to calculate the average of the total of all the values. Look at this error is around coming at 19%. I think this looks good, but we need to optimize this. Okay, so what you get, our mean, this is called mean absolute percentage error, right? Which is coming around 19%. So let's optimize this. Before optimizing this, I'll just try to create a graph between the sales and the funnel forecast. Let's see how they are mapping. So let's go to insert and create a line chart. Look at here, there's some kind of gap is there. So that's good enough. So let's see whether we can optimize this model, whether we can reduce this error and create a good mapping between the forecast and the history. So for that, I'm going to go to data. I'm going to go to solver. I'm going to define my objective. The objective is that I want to choose this one and I want to minimize this. I'm going to change my variables. My variable cells are this one, these three, and I'm going to add the constraint. The constraint is that the sum of these three has to be equal to 1, right? Second constraint is that I'm going to choose the three values. I'll say that this should be less than 0.85. Okay, I'll add this. I'm going to choose these three values, and I will define them as this should be more than equal to zero point 0.1. Okay, so let's add this, and now let's solve this. I'm clicking on solve now, as converts to the current solution, which is coming around 7%. Look at now the graph between the sales and the forecast. Now it looks more replicative. And error, which was 19%, came down to 7%. Right? So this looks a very good forecasting model. Alpha is coming around 0.38, beta is coming 0.1, gamma is 0.85, right? And the sum of these two values is equal to 1. So this looks a promising model. So this is the first model which we have applied. So there's a family of Holt-Winters model, right? There are family of Holt-Winters model. We can try n number of combinations, right? There's a lot of this particular combination gives us a lot of creative freedom to try n number of ways we can actually frame this particular Holt-Winters model. For that, we need to understand the combinations of patterns, right? The combination of patterns, and we have to understand the damping effect, which comes to the trend component. So there are multiple ways we can frame this forecasting model. We should look for the creative freedom within this Holt-Winter framework, right? So guys, this is what I wanted to share with you on this particular uh, session or the video or the podcast. And we will be coming up with some more programs on Holt-Winter method, and then we will share I think more different kind of options or possibilities in the Holt-Winter or other forecasting models. So please do sign our social media channels. You can visit www.mathnal.com, mathnal.tech. From here, you can join our social media channels, and if you want, it will be very beneficial for you because you'll be getting a lot of information on demand forecasting, supply chain optimization. So a lot of content we'll be posting. So please do visit our channel, our website, and join our social media channels like Twitter, YouTube, Facebook, LinkedIn. So you'll get a lot of informative videos. This. So I would like to take leave, and if you want to connect with me, you can also connect with me on my WhatsApp number, that is +91 8977 924 637, and I will be able to answer your queries. So guys, I'll take the leave and have a good day and good evening. So we'll take care of your taking care of your needs, and we'll connect.